Hi, this is lesson 0.4, distance, and it's following the Pythagorean theorem, and as you will find out, basically Pythagorean theorem and distance formula are interchangeable. So I attached some examples, but I want to go through them. What's attached is just the original if you have trouble seeing what's on my board, but working through it is on here. So the first situation, okay, there's two different ones here. The top has E to F drawn on a graph, the other E to F with the specific coordinates listed out. E to F, they want you to find the distance of. It's just a plain line segment, but if we connect it correctly, we can make E to F be the hypotenuse of a right triangle. And if it's a hypotenuse of the right triangle, we can find it using a squared plus b squared equals c squared if we know how long a and b, or the two legs, are. Well, we can count them on a graph. So from E down, 1, 2. From F over, 1, 2. And so it appears the two legs are 2 each, and we need to find the hypotenuse. So we fill it in. 2 squared plus 2 squared equals c squared. Pythagorean theorem, what you just learned. And 2 squared is 4. And 4 plus 4 is 8. And the last step, last time, taking the square root of each side, the square root of 8 equals c, or breaking it down, 2 square root of 2 equals c. Or if it's in decimal, it's about 2.8. Okay. There is such a thing as a distance formula, but truly the distance formula is just taking this apart. Let's think about it a bit. Here's the two numbers. If we just look at the y-axis, we counted that it was 2. But if we start with this number 3 and this number 1, what do we do to get the answer of 2? We subtract, right? 3 minus 1 is 2. Negative 3 minus the negative 1 is negative 2. That being the distance is 2. So let's look at this. This is the first x and the first y. The second x and the second y. We said we subtracted. So the first x minus the first y, the first y minus the second y. And let's look at that. The first x was negative 3 minus negative 1. 3 minus 1. Then what we did was we squared both of those. And they were leg squared plus leg squared. We added the two legs. And at the very end, we took the square root. That right there is the distance formula. Okay, so then let's do the math just to see if it matches. Negative 3 minus a negative is negative 3 plus 1 is negative 2 squared. 3 minus 1 is 2 squared. Take the square root, get the distance. And look right here. Negative 2 times negative 2. Negative times a negative. Once we square it, we always get a positive answer. Positive distance, positive answer. Square root of 8 matches exactly. 2 square root of 2 if they want exact, or 2.8 if they're okay with decimals. Okay, so that's basically it. Now I'm going to turn it to me, and I want you at home to try. Whoops, I'm not ready quite yet. I almost had it. Okay, the second example. Here's J. Here's K. Give you a second to count. Or here's J, negative 1, negative 2. Here's K, 4, negative 3. And you could put that on graph paper, or you can do the distance formula. Either one you want. I'm going to do both while I turn it to me so you're not looking, and then you can see if you get the same answer. Okay. Now, either way you would have done it, you should get square root of 26. Either way. Either you're counting 1, you're counting 5. 1 squared plus 5 squared equals c squared. 1 plus 25 is 26 equals c squared. Last step, square root of 26. Or taking the coordinates, the x's, -1 minus 4. -1 minus 4 is -5. -5 squared is 25. Or -2 minus a -3, which is plus 3, comes out 1. 1 squared is 1. 25 plus 1, square root of 26. So either way, you always come out with the same answer. So I have a paper for you to work on. If you do it, you'll be set up so that you can do the evidence. Thank you.